Going to talk about the variance of a random variable, the spread. First, let me give you a few examples where the expectation or the expected values are the same. Suppose W is always 0 and P of 0 is 1. Suppose that Y can take on the values -1 and 1, and the probability of -1, I guess, is 1/2, and the probability of 1 is also 1/2. If you multiply Y by P of Y plus Y times P of Y, you'll get 0. E of Y is identically 0. If you multiply the only value of W by its probability, you get 0. E of W is 0. Let's look at Z. Z is another random variable. Z takes on the values -96 and +96. And the probability of -96 is 1/2. And the probability of +96 is also 1/2. If you multiply those two numbers, you get negative whatever 96 times 1/2 is. Here, you add it right back. That is, you're going to get 0. E of Z is 0. Here, the random variable had no spread. It was always 0. There's no variance. Here, it varied between -1 and 1. Here, it varied a bit more, 96 or -96. But nonetheless, the expected value is 0. In other words, if you played a game, okay, you toss a coin. If heads comes up, you lose $1. If tail comes up, you win $1. So either you win $1, you lose $1. You play long enough, you'll be even. Now we're going to play the same game again. If heads comes up, you lose $96. If tails comes up, you win $96. If you play long enough, you'll be even. But the variance is greater. For example, if at some point playing this game here, you had 10 more heads than tails, that is, you're 10 behind. Since it's only $1 a game, you win $1, you lose $1, you're $10 behind. Over here for Z, if you're 10 heads behind, you have 10 more heads than tails. You lost 10 rounds. You're behind 10 rounds in this game. That's $960. In game number 1, W is quite boring. If you get a head or a tail, you win nothing, you lose nothing. You'll always be 0. So there is a valid point when one says, well, what's the variance? How much does it vary by? The larger the variance is, the larger this system varies by. This random variable will vary more or vary less. In the first problem I just put up, there's 3 cases. V, I would suspect the variance is 0. And I meant to say for W. For X, the variance will be some positive number. For Y, it would be even larger. Z varied more than Y. try to bring it back. Okay, z varies more than y. Z went from, you either got 96 or negative 96. Y, you either got 1 or negative 1. So there's our motivation for a variance. Just knowing the expected value isn't enough. The expected value in all three cases were 0. Okay. So now, naturally enough, we're going to define the variance of x. If x is a random variable, then the variance of x, denoted by var of x, the variance of x is defined by, or as, the variance of x. Now we have two formulas. Sometimes it's friendly to use one, sometimes it's friendlier to use the other. It's the expected value of x minus mu squared. Mu is the expected value. Or it's e of x squared minus the expected value of x all squared. The expected value of x squared minus the expected value of x all squared. Okay. Let's consider our first problem. Let x equal the result of our toss of a fair dot. Unless otherwise stated, it's fair. Okay, so we want to find the variance of x. We want to find the var of x. In my opinion, I think this formula would be nice. I think that formula would be nice. So we need to find e of x squared and e of x and then square it. So we have x, we have p of x, and we'll have x squared. And as you know, the values that x can take on, x is the result from a toss of a die. It can either be 1 or 2 or 3 or 4 or 5 or 6. And the probability of any one of those 6 numbers is all a sixth. The probability that a 3 comes up is a sixth. The probability of 5 comes up is a sixth. Same for 6 itself. Now, to calculate e of x squared, I need to multiply all the x squares by the p of x's. Well, I don't have the x squares, but I have the x's. The x's are right on top. If I square them, I'll have x squared. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So e of x squared is 1 times the 6 plus 4 times the 6 plus 9 times the 6, etc. The 6 can factor out. In fact, you can divide by 6. You get 1 over 6 plus 4 over 6 plus 9 over 6 plus 16 times the 6th, which is 16 over 6, plus 25 over 6, plus 36 over 6, which is 10, and 40 is 50, and 70 and 80, 91. We get 91 over 6. That's e of x squared. Well, as the formula over here says, var of x is this. Well, we have the first one, the first part. We have the e of x squared. I'm going to erase some work up here, and now we're going to find e of x. And once we find e of x, I'm going to square it. Why am I going to square it? Because it tells me, it says, hey, take e of x and square it. Now you can argue, and I will give in 100% that we did this already. In fact, I'm going to put the 91 over 6 up here. (91 over 6). That is what e of x squared was. And underneath, I'll put in e of x. Now, I was about to say, you can say we've already done this problem, and it's 7 over 2. E of anything, you take the anything, which are x values, and you multiply them by the probabilities. You multiply 1 by a 6, 2 by a 6, 3 by a 6, etc. You can divide by 6. That's 1 times the 6 is 1/6, plus 2 times the 6 is 2 over 6, plus 3 over 6, 4 over 6, 5 over 6, 6 over 6. And what you are going to get is 7, you're going to get 21 over 6. 6, 10, 15, 18, 20, 21 over 6, which reduces to that. Now I can find the var of x. It is e of x squared, 91 over 6, minus e of x all squared, 7 over 2 squared. It's 49 over 4. 91 over 6 minus 49 over 4. The common, we're in subtraction. The common denominator is 12. I'm going to multiply top and bottom by 2. That is, I'm going to multiply by 1. I get 182 over 12 minus, I multiply top and bottom by 3, because 4 times 3 is 12. And 49 times 3, I guess, is 147. You subtract, you get 35 over 12, and you say that's the expected value. Excuse me, that's the variance of x. The variance of x is this subtraction, which is 35 over 12. Let us attempt another problem. Now, if you think about it, if you take all the values that the random variable can take on, and let's suppose that the variance is k. Take all the values that x can be, and you add 17 to them. Okay, if you take each of the values that x can be, and you add a constant, the variance didn't change. The variance didn't change. If y can take on negative 96 and 96, well, the spread is 182. Well, if I add 4 to each, you get negative 92 and 100. The spread between them is still 192. If I add 96 to each of them, you add 96 to negative 96, you get 0. If you add 96 to that one, it's 182. The spread doesn't change. If you add a constant to the random to all of the random if you add a constant to all the values that the random variable x can take on, then the variance of x won't change. Just like if you add a constant to the value that a random variable can take on, the expected value will go up that amount. For example, if you get a 72 on a test, and then a 78, and then a 76, trust me, your average is 76. Okay, and your teacher comes in one day and say, look, these grades aren't high enough. I'm going to give everyone 5 points on every test. Now curve it. That is, now you have a 77, an 83, an 81. Well, your average is also going to go up 5. But the variance didn't. These numbers here vary the same, whatever that really means, the spread of those numbers, it varies as much as those. It varies as much of those. 72, 78, and 76 has the same variance as 72,000, 78,000, 76,000. The variance doesn't change. But the average does. Expected value does. So we have this theorem that the variance of x plus b is just the variance of x. And you should be able to prove this, because hopefully your teacher gives proofs on his or her exam. The variance of x plus b. Remember, the variance of x is equal to, it equals to the expected value of x minus mu squared. That was the alternate definition. And mu is the average. It's the expected value. When you toss a die, what's your average roll? The answer is 7 over 2, 3.5. So the variance of this is the expected value of x plus b minus the average. Well, the average of x is mu plus b. And this gets squared. Now, the nice thing is plus b minus plus b, that cancels out. All that's left in those brackets is x minus mu, all squared. And that is the definition of the variance of x. So we prove that. I'm going to give you another comment or another theorem. We won't prove it, but it'd be proved in a similar fashion. In this case, we're going to look at the variance of ax plus b. Well, we talked about the b having nothing to do with anything. You don't really need this step, but this is the variance of ax. And if you work it out, it's a squared variance of x. Don't worry about this one. The variance of ax plus b is a squared variance of x. And of course, if you had the variance of just ax, you may say, well, it's not in this form. Well, of course it is. You want a constant? Not a problem. Add 0. Okay, now using the formula above, it's a squared var x. So the constant you ignore, and the coefficient of x comes in front as that value squared. give you, so those are a couple of theorems, and I'll give you a definition now. And it's a very simple definition, provided you remember it. The square root of the variance of x is called the standard deviation of x. Standard deviation of x. In symbols, the standard deviation of x is nothing more than find the variance and just put a square root on top. There's no real formula for it, and you want formulas. The formula for variance of x is e of x minus mu squared. You take the square root of that, you have the variance. Another formula for variance of x is e of x squared minus e of x, where just e of x is squared. That's the variance of x. You put a square root symbol over it, it now has a new name. It is called the variance, their standard deviation. Just compute their variance and put a square root symbol above it, and then it has a new name. That's all there is for finding the standard deviation. Find the variance, put a square root symbol above it, and say that was not bad. All problems should be that easy. Well, maybe it's not that easy because maybe it's hard to find the variance. But once you find the variance, then it's very, very easy to find the standard deviation. Just take the square root of it. If the variance is 0.4, well, then the standard deviation will be the square root of 0.4. Okay, now here's a nice problem. You have to think. Suppose you are told that the expected value of x is 1 and the variance is 5. The variance of x is 5. And they want you to find the expected value of 3 plus x squared and the variance of 3 plus 4x. Okay. So to do A, we have the following. 3 plus x squared, 3 plus x all squared is the expected value of 3 squared plus 3 times x times 2, 6x plus the x squared. Expected value function is actually linear. This is e of 9 plus e of 6x plus e of x squared. Now the expected value of the random variable 9, it just takes on 9. So what do you expect the random variable to be? In the long run, it's going to be 9. Now, if you have a number of tests and your average is whatever it is, if your teacher now comes in and says, I'm going to multiply all your grades by 5. Okay, you have a 51, you have a 50, you have a 49. It's a 50 average. Teacher says, I'm going to multiply your average by 5. Well, this average is 50. This average is 5 times 50, 250. This is 250. That's 5 below, but that's 5 above. Your average is 5 times. So this is 6 times e of x. Now, which we know. We know what e of x is. Plus e of x squared. So we're almost done. It's 9 plus 6 times this, which is 1, plus, well, we don't know that yet. And you're like, oh my, how do we do this? Well, you use the other piece of information. It's not necessarily true that that other information is only needed for part B. There's no reason why that needs to be true. Okay, that other piece of information, var of x is 5, that can be used to find e of x squared. Now, remember that the var of x this one, for some reason, is troubling me for a moment. Now, the var of x is e of x squared minus e of x all squared. But we know the var of x. That was given. Equals. We don't know what e of x squared is yet. Minus. Well, we know what e of x is. They told us it's 1. When you square 1, you get 1. You really, really should know that 6 minus 1 is 5. E of x squared is 6 plus 6. 9 plus 6 is 15 plus another 6 is 21. That is the answer to part A. E of 3 plus x all squared is 21. Okay. Now, to do the next one, adding this 3 didn't do anything. Remember that the var of ax plus b, or the var of b plus ax, you can ignore the b. It's this number squared times the var of x. That is, it's 4 squared, positive 4 squared, well, I guess that doesn't matter, 16 times the var of x. But we can easily figure out the var of x. It's e of x squared, which is 6. Actually, we have it here. Oh, I'm sorry. We were given the var of x. It's 5. We were given the var of x. It was 5. 16 times 5 is 80. So there it is. No big deal at all. Just know that this number comes in front squared, and you could ignore this 3. Okay, so you can just look at that and say it's 16 times the var of x, 16 times 5. So the second part only used this piece of information. But to do part A, to use part A, we actually use both pieces of information. And sometimes that's true in math. You need to use more information. You need to use one piece of information, or 2 pieces, or sometimes 22 pieces of information. Okay, so you should definitely know how to do such a problem. Now, let us do one more problem. Suppose you have 4 buses. You have 4 buses, and they hold 148 people. Bus number 1 has 40, bus number 2, 33, 25, that's 70, 98, and the last bus has 50 people. Okay, bus 1, bus 2, bus 3. Number of people or passengers in bus 4 is 50. Okay. Now we're going to define some random variables. Choose one passenger at random. Let y, well, why don't we start with x? Let x equal the number of passengers on that bus. Let x equal the number of passengers on the bus with the chosen passenger, the one you chose here, the chosen passenger. Okay? Now, gonna change it a little bit. Choose one bus. Let y equal the same thing as x, the number of passengers on the bus. Which bus? The chosen bus, the one you chose right here. So I define my two variables. And just to save space, I won't state the question, but we want to find the variance of x and the variance of y. So remember that the variance of x is e of the expected value of x squared minus the expected value of x, and then we square that number. Okay, so we have x. We're going to have p of x, and we're going to have x squared. Now, what can x is the number of passengers on the bus with the chosen passenger. So what can x be? Well, it can be either 40 or 33 or 25 or 50. What are the probabilities? What are the probabilities? So you're choosing a passenger. If you for x to be 40, that meant you chose a passenger from bus 1. The probability you choose a passenger from bus 1 is 40 divided by 148. From bus 2, 33 out of 148. 25 over 148, 50 over 148. Now, what is x squared? Take the x's and square them. 40 squared, 33 squared, 25 squared, 50 squared. Go and square them. You can do it. Equals the first expected value of x squared. So I take x squared and I multiply by the probabilities. And every time I multiply x squared by the probabilities, the denominators are all 148. So you have, first numerator is 40 squared times 40, just 40 cubed, plus 33 squared times 33, 33 cubed, plus 25 squared, plus 50 squared. That is e of x all squared. Now what we're going to do is we are going to compute e of x and square that value. If I forget to square it, then I'm wrong. Just remember I should be squaring it. E of x, it's going to be 40 x times p of x. It's going to be 40 times 40 over 148. 33 times 33 over 148. 25 times 25 over 148. They're all going to have 148 on the bottom. The numerators are going to be 40 times 40, 40 squared, plus 33 squared, plus 25 squared, 40 squared, plus 33 squared, plus 25 squared, plus 50 squared. And this number gets squared. And if you do the arithmetic, which looks like a mess, you will have the variance of x. Now, let us compute the variance of y. And you may say, well, x and y are the same. They have the same meaning, which I 100% agree with. So therefore, they should have the same variance. Well, the answer is not necessarily yes. Not if the probabilities are different. It's all in the wording, folks. We have y, p of y, and y squared. Y is the number of passengers on the bus. 40, 33, 25, 50. P of y. Now, y is the bus. You choose a bus. What's the probability that y is 40? Well, that's if you chose bus number 1, which has the probability of a quarter. Because you randomly choose the bus. It doesn't matter how many people on the bus. The chances you pick bus 2 is a quarter. Bus 3 a quarter. Bus 4 a quarter. Okay, now y squared. Take y, 40, and square it. Take y and square it. Y squared. 50 squared. And now we are done. The variance of y is e of y squared minus, used to be close brackets, minus e of y, and whatever that is, square that result. But we have e of y squared, at least a way of getting it. It's y squared times the p, y squared times the p. And we're always multiplying by a quarter, which is the same as dividing by 4. That is, we're always dividing by 4. It's going to be 40 squared over 4 plus 33 squared over 4 plus 25 squared over 4 plus 50 squared over 4. That's e of y squared. Now we are going to do e of y, and I've already squared it. E of y. E of y. You take y's and you multiply them by the probabilities. And all the probabilities are a quarter. Instead of multiplying by a quarter, you can divide by 4. You are going to have 40 times 1 plus 33 times a quarter plus 25 times a quarter plus 50 times a quarter. And up to doing your arithmetic, there is your answer. This completes the section on variance. And for the record, if you wanted not the variance, but if you wanted the standard deviation, take the square root of the whole answer. Whatever the variance is, take the square root of it.